Ladies and gentlemen, today I would like to present a part of my PhD project. I will present the results of numerical modeling of suspended sediment dynamics in the Mekong Delta. Here is the outline of my presentation, including introduction, methods, research, conclusion, and outlooks. Uh, some of you may know about the Mekong Delta or Mekong River. The Mekong Delta is one of the largest deltas in the world. It happened from over 6,000 years ago in response to decelerating sea level. It covers an area of about 60,000 square kilometer, and is home to about 18 million people. And the Mekong River is one of the largest river with a length of about 4,000 4,400 kilometers, and its range catchment around um, 795,000 square kilometers. And the Mekong Delta begin at Roben, where the the Mekong River is separated into two branches, namely Mekong and Basak branch, or they are called Sông Tiền River and Hậu River in Vietnam. The Mekong Delta is facing several challenges due to climate change and human intervention. In the upper of the Mekong Delta, there are a number of hydropower dams have built and planned on the Mekong mainstream. As you can see here on the left-hand side figure, the structure change flow and sedimentation in the Mekong Delta. Uh, Beside, in the Vietnamese Mekong Delta, the local authority have built hydro system to protect rice field during the high flow season. And the hydro also uh, prevent prevent sedimentation on the floodline. Therefore, human intervention has considerably changed sediment dynamics in the Mekong Delta. Is the recent result of shoreline changes in the Mekong Delta. It's clearly show that erosion is much higher than accretion. Therefore, my study aims to investigate sediment dynamics and derive a sediment passage for the Mekong Delta using a process-based model. Um, to apply a numerical model for the entire Mekong Delta is a challenge because it is a large delta with a dense river system. So we use a multiple dimension approach consisting of 1D and 2D H uh, dimension. Um, the 1D element uh, is for uh, 1D element is for primary and secondary canals in the Vietnamese Mekong Delta, and 2D cell for mainstream floodlands and the cell. This is an illustration of the Mekong river system in modeling. You can see the purple lines are 1D elements and the 2D cells are in black. The 2D, the 1D elements has a uniform of around 400 meters, while 2D cells are various depending on the shape of the river. For example, the length of 2D cell at the confluences are about 200 meters and increase to 2,000 meters in the south. We consider wave effect on suspended sediment uh, in the south. So we consider the we're coupling the wave modules into the hydrodynamics and sediment computation. You can see on the left hand side, no, on the right hand side is the wave width, and for the model setup, we use upstream discharge time series and suspended dynamics concentration derived from the rating curve. Um, and the downstream water level boundary condition are astronomical components from the global tidal model TPSO version 9.1. The cross-shore boundary defined as a Newman astronomical boundary condition to allow a long-term current. And for the sediment modeling, we consider only one fraction of cohesive sediment. And the graph here uh, to show the suspended sediment concentration derived from the different rating curves. We use the rating curve of Cochrane in 2012 because there are differences between the rating curves in different study because of different periods and the input data. So I choose the Cochrane in 2012 for my study because the time is quite uh, reasonable to my cymatic period. Here is the result of calibration and validation of water level for the year 2000 and 2001. Um, in general, we're using NASA Cliff efficiency to indicate the model performance. Here is the values of NASA Cliff efficiency. In general, the values are higher than 0.75, which indicate very good agreement between measure and simulated data. Only some stations on the secondary canals are poor due to the effect of the local structure. Um, Here you can see it's like in the one of project. And here's the result of calibration and calibration of the suspended sediment concentration and sediment fluxes. It showed that the set of critical base shear stress of 0.3 Pascal and erosion gauge of 10 minus 6 kilogram per square meter per second with accurate model results compared to the observation. Um, the reasonable box are defined by the indices of skew and bias. We found that it is difficult to get the best result for all stations because like it means that the all station will be within the box because the uniform values of parameters over the domain. But the results here are quite reasonable for sediment modeling. Uh, this figure presents a calibrated parameter set. Uh, as you can see, here's a suspended. It's a calibrated parameter set for sediment concentration. We don't use settling velocity for calibration mm, because the values of the settling velocity are well measured in many measurement. So we only choose critical message thread and erosion gate for calibration. And here is the result of suspended sediment concentration over the period of 2011 and 2013. And it indicates that the model are quite stable over the period. And to calculate the sediment budget from over the Mekong Delta, we use the period of from June 2011 to May 2012. We analyze and estimate sediment budget in detail, but I don't think I have enough time to present all of the results here. So I will present sediment transport at the three sessions. Um, at the input of input of the Mekong River. Here is at Karachi. The Mekong River supply about 100 million tons of sediment to the Mekong Delta, and the Vietnamese Mekong Delta receive about 80% of the total input sediment, while only 33% of sediment exported to the sea. And this is the new result of sediment budget in the Mekong Delta. My study filling the gap in the in the past. Uh, so because there's so many so many models. It's a 1D model to compute a uh, settlement changeable in the Mekong River. But I think you may know that the limit of 1D model is cannot calculate the sediment exported to the sea. So this is the new finding of my result. So uh, yeah, this is the result of my presentation, my PC version, and so that's all. Thank you very much for your attention. And if you have any question, please ask me or send me an email to my email address here. Thank you.